Really compared to whatever city USF is in.
That's in Tampa, and I much prefer
Okay.
So I don't like it hot, and I also don't like hurricanes. We actually moved out during Hurricane Idalia, so that was really, really fun. That was the worst day of my life because the hurricane came before our move out date, and we were like, well, we already have the moving truck. I guess we'll just move rather than like fit in a hurricane. And so we also were expecting to have my mother-in-law to help us pack up stuff. We didn't have movers. Well, that flight was canceled.
Oh.
And so wife and I had like a 14-hour day of finishing moving everything when we moved out at like 11. Yeah, everything was just getting chucked in the truck. And we started driving 11 p.m. the day before the hurricane. We were about 24 hours out every time we stopped to rest.
It was coming after you.
Yeah, right. Because usually we take, 76? You basically go over, follow the coast until you cut across to get, because we were going back to Ohio.
Yeah.
And we actually added an hour or two on our trip to go east through Tennessee more because the hurricane was going either way.
I wanted to get inland.
Yeah, right. The goal was to get out of the cone. Yeah, that wasn't fun.
Yeah.
And also, like, all the prep, even when you're just living there, even if it's not a big one, like, you always have to, like, tear down the labs and stuff, HVC stuff. It's a hassle. I don't know why anyone would.
So you're saying the university relies on like everybody to take care of their space and do things in advance?
Yeah, right. Yeah, pretty much, like, it's that 24-hour is pretty much your last call. Like, you want to be, like, hunkered down 24 hours out. It's,
Yeah.
Forecast tolerances. So on the second to the day before your 24-hour mark is when, like, you'll go into the lab, you'll unplug all the machinery, put everything in the interior rooms and stuff like that.
Windows.
Yep. Not fun. Did that twice, I think, for the lab.
Does sound pretty kind of.
Philly's a little more uneventful with the weather.
Somebody was writing somewhere that there's some kind of cone of protection around the city because of the buildings warming up.
Yeah.
And then the weather gets a little bit bounced to the side.
Mhm.
So we often get these really nasty forecasts that this will be a horrible winter storm. And it just goes a little bit to the north and hits New York really hard.
Right.
If the Eagles win the Super Bowl, you know, all that stuff off the streets.
Yeah.
I wasn't
Crazy celebrations.
Yeah.
But I was here when the baseball team won.
Yeah. What year was that?
2008 or 2009.
Yeah, 8, right.
Was that pretty fun? People enjoyed that a lot.
Oh, that must have been crazier than the football thing.
Really?
Okay. That's when the city started freezing the lampposts.
Oh yeah, keep people from climbing.
And now it's a sport. You
See
see that?
difficulty.
Yeah. Have you seen that? They like have like a yearly like grease
Oh, there's
pole
actually
climb.
competition.
Yeah, they have a grease pole competition climb event.
That I haven't seen.
Yeah.
I think of football fans is more wild than baseball fans. I'm surprised by what you said.
Yeah, I agree. But that was like the first major win of a Philadelphia team in like forever.
Yeah, it's like 30 years or something, right?
Pent up emotion.
So it wasn't, I mean, the last few games, the city was so quiet. And everybody was either at home or in some place to view it. And it was crazy. Streets were empty. In case there's questions, can you have an eye on the LAMMPS workshop? Sure. It's going to be a very cozy private affair.
Jack won't come back.
I don't know. I mean, he has to drop off his kid and then do whatever he needs to do, and then he has time, he shows up.
I think Max said he would be here on Thursday, Tuesday and Thursday, I think.
Huh.
So he might show up soon. I know he bikes it.
Max is the guy who's been sitting up against the wall by.
No, Max was the one that was sitting here. on
That
Tuesday.
trust.
Yeah, he works with Trust, yeah.
So, probably be done with one session. Because I decided it's better to sleep than just sit and do more slides. And these days it's getting really hard to get the energy to do anything. And I really
You see that at the foosball table yesterday. Definitely
Okay,
had high energy.
that may be, well, that's
Energy.
because I haven't done it in a long time. And Fernando is more of a challenge than Andres.
Just a tip, guys, if you decide to play a match for money against X, your hand on your wallet. You're gonna get cleaned out.
You haven't seen real football. So for starters, our table is not even semi-professional.
It's not perfectly leveled, but
Well, but now actually the surface has from the dry air here has been. The players they're supposed to be perfectly balanced. So that if you put the handle in any direction, it should just remain where it is. And then some of them, they just go back up. Because the bars are not straight. I haven't purchased new balls in a while. So they're supposed to be very fuzzy on the outside. So that you can really bend the ball properly. So if you have a very, you can also typically they come with like billiard ball, polished balls, they look nicer. But all you can do with these balls is just hit them hard. You have no control, not much control. With those red fuzzy ones, then you can actually, if you move while you're hitting it, you can add spins and do all kinds of tricks. But they wear out. I mean, the fuzzy stuff gets slowly rubbed off, and then
tennis balls got bring it in.
so. Yeah, then if you play with 2 and 2, that's actually the most fun, but you also need to practice.
Teamwork.
You need to understand what the other's doing. And you need to play to each other's strength. So, I mean, you're pretty good at defending and not so good at shooting.
Mm-hmm.
So I can be more aggressive with shooting. Because if the ball stays front, it'll more likely stay there. And so I have more time to adjust if somebody sends it back. And then in the same way, you have to be more, so I hit your players far too often. So you have to be more aware of when you move them out of the way. And so if you do this for a bit, you get, like I said, if you play the advanced version where you switch between while you're playing, that requires practice because one has to go back and the other has to go to the front. And you can have, with a professional table, you can have much more control of the ball. So like the stuff that Fernando was doing, where he was playing the ball to his own players, moving them back and forth. You're really good. You can do this very well. You don't really need to hit hard because you just move the ball and the other you just trick people into moving somewhere where the ball isn't going. That's the best way to score is really to shoot the ball diagonal to the wall and then have it right
Ricochet
goes.
shot.
Yeah. So hit the corners is just the something, if your aim is not that good, with this specific table, if you hit the corner, the ball hits the edge and gets a spin that will turn it towards the goal.
So
So you know, if you hit them hard, you just have to hit them hard enough that they get enough backspin and then and pull the goal. But then again, Fernando, if he's goalie, he knows that. So, but that's one of his weaknesses. He gets fooled by the small. Yeah, okay, so I would say we'll get started. Okay, so morning, everybody. We're on day 4 of our masterclass workshop. And today I want to talk a bit about efforts in developing LAMMPS, what are good practices, things that we're doing in refactoring LAMMPS to try to modernize it and follow a bit more modern code conventions. I want to talk a little bit about what is necessary and where you get information if you have some code that was written for an older version of LAMMPS that needs to be ported to follow the refactoring changes. And finally, I want to talk about the testing infrastructure, which is a rather recent addition. I mean, in LAMMPS timescales, I think it's by now also almost 5 years that we started on that. And I want to give a few examples and demonstrations of how these tests work and what you can test. Because there's multiple levels and the documentation is kind of improvised on that and incomplete because it's a lot of work. And just to get the tests in there is usually the higher urgency than having it all documented in detail. Because it's very few people so far that actually cared about writing tests. So just to give a bit of background, it is important if you look at LAMMPS to understand that it's a fairly old code base. And that was originally written in Fortran 77, then updated to Fortran 95, which are effectively the same. That went until about 2000, when, as far as I was told, the integrating contribution, integrating new styles became a bit of a hassle and more complex with Fortran. And then it was basically translated to C++ with an intent to keep the data layout and the code structure similar so that people who are familiar with the Fortran code wouldn't have too much effort to adjust to the C++ code. But that also had some consequences into what were common patterns of how things were done, and they were not necessarily very C++ style. Overall, the programming for C++ was a bit at its infancy, and a lot of the C++ runtime wasn't very portable and reliable across platforms and compilers. So the style for many years of LAMMPS was C with classes. So essentially use some of the C++ features, in particular inheritance and polymorphism, to simplify the code structure and to have some a consistent code flow of code so that you didn't have to replicate a lot, and still could add more and more features into as derived classes of the base classes. But then stick with the tried and trusted C library functions for most of the utility work that you need to do and math and so on. And then specifically meant for a long time that it was a no-no to use SDL and other advanced C++ features. It was tolerated in code that was optional, but not in the code that was in the core that had to work on all platforms. And that went on until about 2020. So we had ongoing discussions for a while, people making requests that they wanted to use more C++ features, but that was then still limited to the add-on code. And then we had some discussions and finally settled that we want to use the C++ 11 standard as the lower boundary, because it would allow us to use quite a few features that make programming more convenient, that allow us to write code that's more easily maintainable. And so we also kind of gradually shifted towards some SDL classes, so C++ strings, and some containers like vector or map. We're still trying to minimize this to not go overboard, but many times there's a distinct advantage, and by now we don't have to worry about reliability of the template code, the SDL code. So that's why we have now some of us, so most of the time right now it's me, it's a few other developers that also spend time in the past of refactoring code to be a bit more following modern C++, even though real C++ programmers consider C++ 11 already outdated and way below what is good to use. But our focus is still on portability, and kind of the gauge is what's the oldest Linux distributions that are in wide use, and that's currently CentOS 7 or Red Hat 7 and Ubuntu 20. It just went to the point that it's out of service. So and so that's where C++ 11. So Red Hat 7 is C++ 11 support isn't even complete. But it works for practically everything we use in LAMMPS. That's one of the reasons why we also try to moderate the C++ uses. So that's the one thing about the programming style and language support. Another thing that has been in LAMMPS since the very beginning is that LAMMPS tries to follow a continuous release a development strategy, which means that the LAMMPS code should always be usable. And that if there's a bug, we try to have it fixed and committed to the development version of the code as quickly as possible. But that wasn't always perfect in the past, because there was no automated testing, and Testing was often restricted to whoever the LAMMPS developer was that was integrating a code, was using at the time. So if there was a conflict or an incompatibility with some other package, it went undetected. So Steve and I had some fun with the OpenMP package when he was making changes to the base code that broke stuff in OpenMP. That was a bit of a hassle. So this is now much harder because of the automated testing. And there is essentially something we call unit tests, although I'll get into more details on what that encompasses later, and regression tests where we basically try to run many of the examples from the LAMMPS distribution and reproduce and check the results of that. So this testing all by itself already has reduced the number of issues because they were detected before even code gets integrated into the development version. And this is why we now have a set of 4 main branches in the repository for specific purposes. So the main branch, which is what the developers use, is called develop. This is the leading edge of the development, and everybody who programs LAMMPS or wants to add stuff is encouraged to do this based on the develop branch. And if you're working on something that takes longer to program, you're encouraged to merge from upstream so that when you submit your stuff as a pull request, it will not be too far away from the development head. The integrated testing, the automated testing, will always merge with the development head. So you may just get warnings or errors about merge conflicts or things that don't work because you don't have those changes in your code and you haven't adapted your code to this. Then we have the release branch. So this is for people who want to follow the releases without following every development. So in the develop branch, there are sometimes cases where bugs escape the automated testing, or some very time-consuming tests are not run on the pull request, but only run after the merge. And sometimes, not always, do we notice that something is broken. So it can happen that something in develop is broken and then needs to be fixed. And we try to have this fixed for the release. So there's a very simple procedure. Basically, the last pull request that's merged is the pull request that adjusts the version number, and that, if you do it right, never breaks anything. So if it's clear before, then I can merge this one and can be very confident that none of the special tests that run only on the develop branch give a problem. So it just requires to wait a little bit. And so the one thing we have to be careful is you cannot really do a merge thing, because that confuses the hell out of the testing server. And that also has a limited capacity. So once you're queuing up too many pending tests, then it gets really dicey for that machine. It's very old hardware. So release is then basically a fast forward. So it essentially is a snapshot from the development branch where we say, okay, this is complete for a certain set of features. And so that's where we're confident that people can use it. In addition, we have the stable branch where we do a release about once a year. And for that, we also have a period where we say the one release before that, we only put in bug fixes so that we have a sort of stabilization period where code that was recently added is still tested. There's far fewer people that use the release version than the stable version. So it always takes a little time until people notice that there's something wrong. So, and also from the merging, anything that's a more aggressive change, if it's been submitted right before the stable release, it may actually be postponed for several months until after the stable release, so that has a good chance of being shaken out by regular use and also developers. I haven't really made any statistics, but I think it used to be that we got quite a few bug reports. They have become less, and we're noticing things by ourselves sooner. So overall, I think the overall reliability of LAMMPS has quite significantly improved this. Yeah, so the feature releases, that still changes a lot with how many features are submitted and who's doing it and how much time we have to merge. So sometimes it can happen that because people are busy, that the release will take up to 3 or more months. And sometimes we have a lot of stuff and then it's a bit shorter. But the difference between the release has been growing, but previously patches were effectively what the develop branch is now. So one really has to think that there is still the same continuity, but now the only difference is that previously there was a patch whenever something was added, and then this has become the release, which is actually then just the declaration from us that the develop branch has reached a point where recently added features are all complete and working, and we don't have any problems where we know that something needs to be fixed. So, and then for the stable release, there is an addition now, and I think I started this like 2 years ago, that an effort was made to backport any bug fixes. At that time, there was sometimes quite a few, and there's still a sufficient number, specifically in the newly added code, that just corner cases, things that were not considered because people are trying to use LAMMPS in ways that nobody has anticipated. With software that is as flexible and modular, there's just an almost infinite number of permutations of how you can use features, and it's impossible to test this ahead of time. So now we have also updates to the stable release, and for that there's a fourth branch, maintenance, where most of the time, if possible, if there's a bug fix commit in any of the pull requests, this will be cherry-picked into the maintenance release, and only occasionally it needs to be backported and adjusted because some of the stuff that's in the develop branch is not available in the maintenance branch. So we don't want to add new features, and we don't want to break the binary interface so that people can keep using the same binaries, their plugins and so on.
So 2 questions. So if you're a user and you want to grab the stable 6 months after it was initially released, is the way you grab the stable, does it automatically pick up anything that had been put in the maintenance branch?
Yes, so there are update releases. And so every time there's an update release, that's the similar behavior, similar process as for develop to release. The maintenance branch is fast forwarded, the stable branch is fast forwarded to the state of maintenance.
So if you grab it later, you'll get the best state, basically.
You get the well, yeah. So essentially, if you want all the bug fixes, you're trying maintenance as a branch. But because people, there's a lot of people now that use precompiled binaries, specifically on Windows and Mac OS. So for those are provided in part in packages. There's also RPM, Debian packages, SPAC, and many more. And those usually follow the stable releases. For them, even if we go to 3 months or 4 months for the feature release, that is too frequent for them. And for them to then grab the update to the stable release is a no-brainer because it doesn't change anything unless something external changes. And so that's for them easy to do. That's basically just a patch to the package.
Second Can I ask a second question? So if you're looking at the website and you're looking at the doc pages for some command or something, maybe it's had some recent changes, which of those versions do the doc pages on the website always reflect?
Currently, well, there's actually 3 versions of the man pages available. The one you get by default is for the release branch. And then if you go to the doc page to the lower left, there's a little drop list where you can switch to the documentation for the stable branch. And you can, there where it says latest, you get the documentation for the develop branch. So, and each of those are automatically updated. So that's also in our continuous integration scripts, if there are pushes to the corresponding branches.
Yeah, so the reason I asked that is for users, sometimes people get confused. We can even get confused. If you're looking, the doc page may say one thing, but the version of the code you're running might do something different because it's a recent change or whatever. And so unless you're making sure you're synced in that sense, you don't want to get.
Yeah, so one thing that I've been pushing hard and trying to get people to do is if we add features, the Sphinx documentation language has a macro version edit. So typically during because we don't know yet when the release date will be, during the development cycle, there will be a version edit TBD. And in the pull request where we update the version string, we'll also update that TBD to the same version number. So if you look at the documentation, you will then see on the page where there is a new feature explained, it will say version added or version change with the release date. So you can see at which version of LAMMPS this was added. Unfortunately, many people don't pay attention to those and still complain that something doesn't work when they have a very old version and the feature is flagged as new. But that flagging is also not complete because sometimes it's very hard to figure out where to put it, and sometimes you just forget.
Yeah, so for people who are kind of tied to an old version, maybe because they're doing their own local development in that, maybe you're going to explain this, but you can build doc pages that are in the download that you got, and then you'll have doc pages, obviously, that are exactly for the version that you downloaded. I don't know if you want to tell people how to do that.
No, so basically the recommendation is to do development on the develop branch and keep updating. Okay. There is a few exceptions where that is difficult to do, but and also if people do not plan to contribute it to LAMMPS, it also doesn't matter. And there's a lot of stuff where people say, well, this only works in serial. I don't know how to make it parallel. Maybe the algorithm doesn't make sense in parallel or whatever. So that's stuff where people just keep it as their own. So we had when we did the last virtual workshop, no, not the last one, the one before, we had multiple people who had packages that were external. And in most cases, the reason was that it wasn't out. Like they had submitted it and we rejected it and reviewed that it only works in Screw. But then again, but for most cases, I mean, that's why we have an extra entry in the documentation to list the changes that need to be done to update code that is written for an older version to the current version. That's also not complete because it's done on the case-by-case basis when you notice. I have a few more comments on this, but I'll move ahead. So the next few slides is meant to be a guideline for people. I don't think we have this anywhere. And also, it's a very personal thing. So if you work with Git and GitHub, you can do the same thing in many different ways. And some people prefer it in one way and some prefer it in a different way. So this is the scheme that I have figured out for myself that I found to be very effective. And as some of you know, I've I'm jumping between branches and pull requests quite a lot when I'm merging. So you have to have your account on GitHub, you have to make a fork. And then when you want to work, you first make a clone. If you want to move anything back, it is useful to have an SSH key uploaded so you can upload it passwordless. In fact, the password option as such has been dropped. So you cannot clone with HTTPS and then push and get asked for a password. Instead, you have to use the GitHub command line utility or manually get a access token and store that token. And then you can push again if you clone with HTTPS. So cloning with SSH is in many places more convenient. And the problem with if you clone your own fork, which you need if you want to push your branches, is now you don't have a connection to the upstream repository. And for that, you add a remote, so you can call it upstream, that links to the original where you created the fork from. And then you fetch this, and then you can check out develop, and then your develop branch can be set up to be connected to the upstream develop, whereas any other branch you create will be connected to your own repository. So this way you can make sure that your develop can stay in sync with the develop that the LAMMPS developers are maintaining. And you can easily do a git checkout, git pull, switch to your own branch, git merge, and you have all the changes from the development integrated. So now if you want to contribute something, so for example, one of the things that we're working on is improving error messages. So if you want to work on that, you can create a feature branch, and you want to branch off the develop branch. And if you use the command line like this, it doesn't matter which branch you're on. Otherwise, it will always create a feature branch of your current branch, and that may not be the branch that it should be branched on. Because to be able to merge it, it is almost required to start from develop. Because otherwise, you may include changes that you don't want to get merged, or we don't want to have included. So if you push it, so origin will be your own repository, your fork. You add the -u flag to make sure that these are linked. So if you do a git pull without any arguments, it will update from your own repository. That usually, if you just work on one machine, doesn't make a difference. For me, it makes a big difference because I have a desktop at home, I have a desktop here in the office, I have a laptop, and I may want to work on the branch on any of the three places. So I then need to update or git fetch my own repository, so origin, and then I can check out the branch I want to work on, or when it's already checked out, I can do a git pull and get the updates that are in there. Otherwise, it's very annoying. Then you have the changes, and you have other changes in your repository, and of course, if you want to push those, the repository will refuse them, and rightfully so, because you have to first pull them and merge them into your branch and put them in there. And if you do the pull before, you just get a cleaner Git history and less embarrassment. Although nobody sees it publicly, but I find I'm always embarrassed if I forget to do the pull. It's just, oh, you idiot.
You can back up, commit, and then pull.
Yes. That's the last point here.
Oh, yeah.
So what happens sometimes? So I'll just let me comment on this in between. So if your branch has fulfilled its purpose, so the feature you want to implement is complete, or if you do something like these refactoring things where you can basically keep on working forever, but you don't want a huge pull request. I mean, it happens sometimes simply because we can't process them fast enough. But generally you want to have a pull request that is reasonably easy to review. If it has 1,000 modification to files, then it is a bigger effort than if it's like 50 files or 100 files that are modified. So then you submit a pull request. And once you have the pull request submitted, there may be comments on it. People may ask you to make changes. With the default setup, any branch that's submitted as a pull request will be writable by the LAMMPS core developers. So if there's a change that is more difficult to explain than to do, we may just grab your branch, make the changes, and push it back. So if that happens, you should also always do a git pull if you want to make the updates that we ask you, or that you discover there's something missing or there's spelling errors in the documentation or so on. Git allows you to work on multiple branches. That works particularly well if you're compiling with CMake, because it will rerun CMake as necessary and update for the files. If you do this with the GNU-make procedure and you have changes in the package, you always have to make sure that you update the copies of the package file in the source folder. And it gets even hairier if there are changes in the library part, although that's rare. So CMake makes this easier. But then if you want to merge with the upstream, so you see there's checkout develop git pull. If it's been connected to the LAMMPS upstream repository, will be updated, and then you check out your own branch and you can merge with develop, and then you can push it again, and then your branch is basically up to date with the development changes. So, and some people still do it and submit their develop branch as a pull request. That's actually been frowned upon and makes things a bit messy. So if this happens by accident, you can undo it. So if you do git reset and you reset to the upstream develop state, then essentially the git state will be reset to those changes. So any additional commits that you have done will just become changed files, and you can commit them again. And if you before you want to commit them, if you check out the branch where they're actually supposed to go, then you inherit those changes and you can commit them. In some cases, when you have modified files in those misdirected commits, and also in the branch, you can't do this cleanly. Then you have to do a git stash, check out your branch, and then you can do a git stash pop, and then the changes are applied, and you can continue from there. So this is as far as Git is concerned, the most common things and the most common problems that I run across. So if you and the solutions that I'm using. So I'm cheating. Well, actually, I'm cheating a bit because I use the GitHub command line because that has shortcuts for many of these things, but it's in practice the same thing. So before you submit, you can actually run a few checks that are also run by us on every pull request. And so if you go to the source folder, there's a bunch of Python scripts that can be invoked that check if you follow some of the coding standards. There's things like you have to have the developer at lamps.org in the comments in the header. If you copied an old header file, then it has Steve's old email address in there, and that's not leading anywhere these days. And also it gives the wrong URL. So Sandia still has an alias for lamps.org, but we don't know for how long that will be valid. So it will be better to have it consistent to the current state, and it can be very easily checked for automatically. And there's a bunch of these checks, so it also checks for non-ASCII characters and a few other things that we like to get resolved.
Does it include a white space check?
Yes. Yeah. Yeah, that's the thing. one forgets most common. Depending on what editor you use, it's very easy that it happens that it adds white space, like in between code lines, or at the end if you delete something and you don't delete all the way. So then there's actually, you can see the individual commands, and there's corresponding commands, so they can do check white space or make fix white space, and then we'll try to augment the sources accordingly. Another thing you should do before submitting is to check whether your changes to the documentation are compiling, at least for HTML, and whether the spell checker complains about any unusual things. So for technical documentation, spell checking is always a bit of a problem, because many of the technical terms the spell checker knows nothing about, or we're citing papers and there's lots of people with names that are not in the standard text library of spell checkers, and we have keywords. If you spell check the keywords, it will show up as a word that the spell checker doesn't know. So we have a long list of false positives, but all of us have certain patterns where we make typos in manual text. So I can often tell whether it's a typo from me or from Steve, because we both make the same kind of typo. I mean, he makes a different kind of typo, and I make my own common typo. But you can basically see, oh damn, that was one of mine. And then if you have the time and put in the effort, and again, this is something I'll talk about later, you can also go, if you use CMake, you can run the integrated tests through CMake. So that requires that you build with CMake and tell CMake that you want the testing framework to run. And that has been quite useful, but also that's a topic for later in the talk. There's two links to the manual that also have additional information. Like I said, what I described here is what I found to be effective for myself and to be easy to explain. You may have different preferences, specifically if you're using an integrated development environment, because then you have to adapt to what the IDE does about Git stuff. I have some limited experience with Visual Studio, and for that you have to just do it the Visual Studio way. Okay, so if you want to do LAMMPS development, there's a few things you need, not really much. Basically, if you have a recent compiler and an MPI library, you're in business. But if you do development, specifically for the refactoring changes, where you may do changes in all kinds of places of the LAMMPS group, then it's beneficial if you build LAMMPS with as many packages as convenient. And for that, we have these most presets that should select packages that are not extremely time consuming to build and are not dependent on extra configuration steps, extra libraries or packages you have to have installed. So if you configure with most, you have a LAMMPS executable that has a lot of stuff included. So if you make changes, it's also likely that compilation fixes or clashes that happen due to changes will be detected. Specifically when refactoring, if you change an API in the core code, you really have to check very carefully where this is used and how far this propagates. And that's often forgotten because people tend to only check what they use. So I want to put in a reminder that it's it makes our life easier. And in the end, because of the automated testing, if it doesn't compile with all these different configurations, the automated testing will fail. So if you check for it before, it just makes it easier. And then with the time, you also learn what you have to watch out for. So I believe that having all this stuff enabled helped myself to become a better programmer, to just be more careful. If you want to look up and feel a bit confused about what other packages you need to install, we have put together definition files for singularity containers, now called apptainer. It's basically the same thing. And those description files actually have a list of packages to install so that you have a pretty complete environment. We use these containers in the integration testing. So you really basically, if it works with those packages, then it should work because we will test with the same list of packages. If you're working on Windows, then I would say by now the best bet to get quickly up and running is to install Visual Studio. If you're not a commercial developer, you can actually get this cost free. It's kind of based on the Visual Studio Code thing, but it has the compilers integrated, and most importantly, it comes with integrated CMake and integrated Git support. So you can basically, from within the IDE on Windows, clone and check out the LAMMPS repository or your fork, and it will detect that LAMMPS supports CMake. It will ask you, is this the folder where the main CMake configuration is? And you have to give it the CMake folder. And then it will pick up a specific Visual Studio specific configuration file in that folder, which will also set up the compilation with a list of packages that is almost complete and specifically selected to be ported to Windows. So not everything in the most preset that works on Linux will work on Windows. The example I remember right now is the Quip package, because the Quip library is hard coded to use make, and it is already kind of tricky to work around how to compile this in an automated fashion for CMake on Linux. But on Windows, it's impossible because it depends on Fortran, and Fortran compiler is not bundled with Visual Studio. It's only C++. Microsoft has I don't know whether they can still call it maintained MPI package that works, but it's much better than the one we used previously, which was like 15 years old. Because for the MPI libraries like MPitch or OpenMPI, they are always desperately looking for people that maintain a Windows package of their library. But doing this for Windows is a lot of extra work. And so it doesn't exist. So Microsoft had people paid for, they had like two efforts I remember. So one was about 2005, 2006, where they were trying to push Windows as a cluster operating system. And then there was another one in the 2010s or so, or maybe 50s or so. And that's where this one is from. The old package is actually so much of a problem, you can't even install it on Windows 10 or 11, because for the installer to work, you first have to install a very, very old .NET library. So it's really, this is the best combination. Unfortunately, those different MPIs, of course, are not compatible. So you have to use that one. And also the precompiled packages now all use that MPI and not the old. That was also quite an ordeal to get that package which is compiled with Visual Studio to have the files for the Linux to Windows cross compiler. So Windows porting is sometimes very challenging. And yeah, since we have the singularity file, so if you don't want to change your installation, of course, it's straightforward to use a virtual machine or a container. And then, so if you have a container, there's actually no overhead. And we use this to test different Linux versions. So if somebody reports a bug that is only on Red Hat 7, I have a Red Hat 7 container, and I can check it. Or somebody reports a bug that is only happening on Ubuntu, I have the Ubuntu virtual machine, I have an Ubuntu container for different versions, and I can boot that and do the test there, and when I can't reproduce it on my machine. So sometimes it's just the version of the MPI library that has bugs and hasn't been updated accordingly. One thing that I also want to mention in this context is that we integrated the format or FMT lib library, which is so it has been part of the C++ 20 standard, but it's also an attempt to overcome the horrible performance and difficult interface to use IO streams in C++. So the IO stream programming is extremely verbose, and printf style formatting is a nightmare. Because you have to put so many different, now I want this format, now I want this format, output, now I want this format. So it's really a mess. And on top of that, these people do benchmarks, and they claim that they're outperform even printf, and it's no challenge to outperform IO streams. It's type safe and can do fancy stuff. It does require C++ 11, but with that we can do some really fancy things, so that you can even create your own overloads for your own functions, which then have one string of the argument taken as the format string and can have a variable number of arguments that are then inserted into the format string. So you don't have to go through this FMD format call that outputs the string, but you can have this integrated into your function and have it transparently there. So we have a bunch of functions like in the error class, error all or error one, accept this, so you don't even have to use a complex extra operation where you create the format string and then output the string, but rather you can do this in one go. You can treat error one and error all as if it was a printf like function. And the same is for the LAMMPS tool that prints output to the screen and the log file. So that's pretty useful. And also you can have this, it looks a bit like a format in Python, and I think that's quite intentional. And the biggest advantage is that you don't have to specify a type. If it has a known converter, a known overload, the format library will automatically handle this. And in LAMMPS, this is helpful because we have a few integers that may be of different size depending on how you compile it. And previously you had to do an ifdef and use some macro to insert a format string, and it was all very verbose and error prone. And now you just use the same code and just put in the curly braces, and it outputs whatever number this is correctly. Okay, and yeah, and there's some things. So yes,
You have here the placeholder being the two curly brackets.
yes.
What happens when the message you're printing contains actual curly brackets?
Escape them.
You can escape them. It can also have this thing where you can have nested curly braces, so that you can have the format string be an argument to the format string. Yeah, but there's escapes. But also, so one thing I remember that's not available in printf is, for example, that you can also have output center. And you can decide on what pad character you want. And so with printf, you can have zeros and you can have blanks, but not anything else. And here you can use lots of that. It's very few cases. But for example, we use the centering for the thermal output now, for the header display. So they're more better aligned to the numbers. Okay, so here I have a list of things that I consider like on my to-do list for refactoring, but if I find some volunteer that wants to learn a bit about how to program LAMMPS or feels like this is something could be improved, these are things that could be or should be done also when people want to port code or submit code. I'll point people to that if they use code that's based on old versions of LAMMPS. So one thing is that we're working on, and it takes a while because a million lines of code are just not changing themselves overnight. Is that we change the way how error messages are written and managed. I have more details on that. Same, we're trying to make better use of C++ strings. They have advantages in terms of memory management and usability. So you can't get a null pointer from a C++ string. So you don't have to worry about that. It's the only thing we have to worry now if we pass a C-style string to a C++ string, and that's a null pointer. So that now needs to be checked for. So a lot of parsers that were written in this C with classes style were written using C-style string functions and specifically strtalk as a tokenizer. And that was problematic because it uses a static buffer to keep the string it's been taking the tokens off. And that can be a problem if you have multiple LAMMPS instances and process them, run them concurrently. Most of the time, the tokenizer is used in such a way that it consumes the entire string before it returns. But in general, this should be avoided. And we have actually a tokenizer class where you can pass a string and then you get you can ask for the next word and the next word, and you get them as a C++ string. And there's also a tokenizer that can also a version that can convert strings to numbers, and specifically for the kind of numbers you want. And then integrated is it throws an exception automatically if the string is not compatible with an integer or floating point or long integer or whatever is needed. And then on top of those, we have classes for the rather repetitive task of reading potential files, where the repeated code is just part of the class or the function that you're calling inside the class, so that makes just the effort of processing these files much less. And it has like also things integrated with white space handling and counting of words and so on. So it often, I remember Richard submitting some changes where he could reduce the function that reads the file from several hundred lines to a couple tens of lines. It was quite a bit, I would say. And we have some more utility functions. They are currently spread into two namespaces. There's utils for generic utility functions. And then there's a platform namespace specifically for functions that are different or need a different implementation. So they're trying to be an abstraction of platform functions, platform-specific functions. Like if you need to traverse a directory tree, that's usually different on different operating systems. So one thing that's the most advanced refactoring that I have on my list is the changing the code to have different accessor functions for class members. So there's classes like force or modify that maintain the list of pair styles that are in use or fixes or computes and so on. And the old style, I like to call it Fortran style program, is you have a function that compares the string to the index of that specific style in the list of all available styles. and then you get the number, and then you can look up the pointer to the factory function, for example, or to the instance from the list of all instances through that index. But with C++, we can just return the pointer directly. So there is like, instead of find fix, you now do get fix by ID, and you get the pointer to that fix. Or if you use by style, then you can have multiple active instances of that. So get fixed by style will actually return a vector of pointers, and then you can look at the size of the vector. If it's 0, then there's no fix of that style. If it's 1, you use the 0th element, and if there's 2, then you have to decide whether there should be 2 of these and which one you take, or you can error out and say there should not be 2 of these. And again, the driving force for this is to reduce access to the internals of the classes, because then you don't need to know how the class is implemented. And if at some point in the far, far future, this is kind of complete or mostly complete, then we can even think about changing the implementation of how data is managed inside the class if there is more attractive containers, for example, in C++. So for some cases, using an unordered map would be advantageous and easier to program. And then in other cases, you need the order, like for fixes, we're probably stuck with the current code structure because too much depends on the semantics of how that is implemented. But that doesn't mean we should depend on knowing the internals. It's still a benefit to have these a little bit more abstract accessors so that you just get the information you need more directly. So let me talk a bit about the error message thing. So in this point, this situation, so the way error messages were handled was yeah, I would say it was assuming that the LAMMPS user was also a person that would know how to read source code and would have compiled it from source. Because basically you get an error message, like a very generic error message that says illegal pair command. And that doesn't say why it's illegal, how it's illegal. And that was a contribution some years ago. The error message is always printed with the file name and the line number in the file. So you could always go to the source code and look it up and see what is actually happening there. Is it the error? Is it the illegal pair command up here or down there or somewhere else? And that would give you a hint. But as people more and more use precompiled Linux versions or are non-programmers, so they wouldn't know how to read C++. Maybe if they're programmers, they may be Python programmers and then get confused with some of this. So basically the intent is now to upgrade those error message to provide just the minimum extra information that you don't have to look up the source code, and you can deduce what the error would be from the manual, from the documentation. So if for example, you have a typo in the keyword, then the error message should be, I don't know what this keyword is. And that should be enough of a hint that you know. Or if you have not enough arguments, then it should say, yeah, there are arguments missing to this command. And then it has to be a bit more specific. So like for fixes, they have extra keywords. So then you have arguments to the keyword. And so yeah, error message says fix so-and-so keyword so-and-so is missing arguments. And that's a pretty minimal modification to the source code, but it's pretty straightforward and then makes it much easier for people to figure out what the error is. It's just tedious and it's a lot of dull work. So it's something I do when I don't know what else to do and feel I need to have a little satisfaction that, like when you have, you're very frustrated, a lot of things don't work. these things I can always do right. So that is good for my confidence. If I have some changes that I know how to do after having a day where I didn't know what I was doing. There's still a lot of the old error messages and warnings listed, and you can often use those as inspiration for how to change the actual minimal error message so that you get more information. But there's also a few cases where you can't do this. So the error messages that are added should be not really extensive. They should just provide enough information that can figure it out from the manual. We don't want to have like a source code that is full, that has a second copy of the manual. So it's really like you want to be specific, which keyword failed, how you want to tell if it's unknown. Often if it's relative to a compute or an argument that has to be a compute or a fix or a group or anything, then the error message says, yeah, illegal fix command, but actually what you want to know is, I cannot find the group of this name. And with this change to the error class, then you can put in curly braces and an additional argument that just has the name of the ID you're looking for. The modification is rather minimal, and the gain for the user is quite significant in this case, because it just, you don't have to guess where it goes wrong. You see it, if it's a typo or you use the wrong group or any of that.
Like, so in the error message, we have the line number, right, with that layer.
Yeah,
Is there any way we could just print out the line of, like the line of code, or I guess I wouldn't, that's not that helpful?
and not really, because most of the time where the error message is printed, that you need the if statement before.
Yeah, true, okay.
So, and I mean, from my changes that I've submitted so far, I believe that in most cases, it's really just a couple extra words that are needed. And specifically that you have these extra arguments. And before with the old error class, it was always tedious because you had to allocate a string buffer. You had to sprintf into the string buffer. You had to do the error message, and then you had to delete the string buffer. And that's kind of messy. And now this is just a modification of the line where you just can add arguments and convert this plain string into a format string with optional arguments. I mean, the reason why it was the way it was is not necessarily because Steve is a mean person. It's just, anything else would have just been so much more work.
Steve is a lazy.
Well, so I believe this is the best compromise between laziness and useful information.
So how long, I mean, how much has been forwarded and how, how labor intensive do you think, like how long will it take for us to go through all the lamps and?
That depends on how many people help with that.
Yeah.
And I mean, for myself, I had periods where I could work on LAMMPS almost exclusively. And that's where I had a lot of commits and contributions. Recently, it's the other way around. I have to work on other things and have very little time for LAMMPS. So my contributions have basically been cut into less than half of what it was 3 years ago. So this is one thing I often pitch to people if they say, I want to learn how to program LAMMPS. I say, here's something that you can start with very small increments. So that has worked with a few people, but they had like maybe 3 or 4 weeks of that, and then they just went on to do their own project, which I don't fault them for, because that's why they did this.
Okay, I don't know if you're about, I didn't catch this, but that third bullet, I think, is actually a really cool thing that you've added a capability to do where you get a URL and the error message, clicking on that, your screen or whatever would take you to more. Did you already talk about that?
No, I haven't mentioned, I wanted to talk about it on the previous slide, and I saw that I had to move the button, the bullet. But yeah, so there is a page, errors details, that is now curated to have specific explanations for errors that can have multiple causes or cannot be explained in just, oh, you have the wrong keyword or you're missing arguments or the number is outside the valid range or any of that. And sometimes the explanation has to be quite complex, like lost atoms is something that can have many causes and would need to give people quite a list of things to check out. So that one doesn't have this yet, for example. I think I put it in 2 or 3 places just to demonstrate it, but I never had the time to systematically figure out which are the most posted error messages and people are struggling with on the forum or the mailing list, and then systematically try to put this URL and more detailed discussion in the manual. That's the way how I would go about it if I have the time. Yeah, so for the missing command line arguments, there's a function that can make this easier. I already mentioned the overloaded error classes. So some more details about C++ string versus C style string. So we have in the utils namespace quite a large number of utility functions that can be used on strings. And typically, if a function has a call standard string reference as an argument, C++ knows how to convert on the fly a character pointer if you pass it. So we don't even have to have an overload for the character pointer, except for cases where we need to check for null pointers. Then you have to have an explicit overload that has a check for the null pointer and then handles this accordingly. There's a bunch of things. So you want to have a string split into words. You want to know how many words are in it. You may have a string that is multiple lines. You want to trim white space. You want to cut off a comment. So typically, like in potential files, we have the convention that a pound sign is the beginning of a comment, or in data files. So you can call this function and you just get the string with that thing chopped off. We're also trying, because there has been a problem that's becoming more and more common, that people cut and paste text, but the text is transparently converted to use UTF characters. So if you look at the web page, parentheses or the quotation marks may actually be changed, or even the blanks may be changed to make the string look better. Because there is UTF characters that are beyond the ASCII codes that look the same, but fit under certain circumstances or look more pleasing. And web browsers do this, PDF viewers do this. So people cut and paste text from the website, put it in the input, and then of course, since we're parsing only ASCII, then the parser doesn't know what to do with that. And there is now a list of known UTF characters that are equivalent to ASCII characters, and this function can do a substitution of that. So files, even if they should throw an error, if it is a known substitution, it will be fixed.
So we do that now when we read lines from people's input scripts. We do this conversion to take out any funny characters.
Replace them, yes.
So that'll help ChatGPT make the right LAMMPS code from all the web pages. Search.
Absolutely, it can use what the web page has without knowing what it does. Yes. So one of the most useful of these additions is that I found a very minimal regex parser. So it's a small C code, and I customized it so we can use it for character classes that are important for us, like does this represent a floating point number or does this represent an integer number? And so we can do a regular expression match to strings. And that in many cases has reduced lists and lists of if statements for for example, for if you want to check for fixed rigid, you had to know every variant because it was doing a full string compare. And if you would do for some of these programs, for some of these strings, you cannot do a substring search because the substring may show up in other fixes in a completely unrelated fashion. And with the regular expression, you can put the little caret there and rigid, and that it will match any string that starts with rigid, which is by convention all the rigid fixes. So we can replace the 20 or so if statements that were or string compares with just one statement or two. And you can do the opposite. You can also do the dollar at the end. And this way you can sort out any strings that are for suffixes, for example. And there's a few in between, but this is I would say by far the most useful application that you can search for a whole family and you don't have to check for the suffixes. Yeah, I already mentioned this. So there's a class tokenizer where you can process a line of text and it will give you next will give you always the next word, and value tokenizer where you can explicitly ask for give me the next integer or the next floating point number. And there is text file reader and potential file reader that are somewhat tailored for repetitive tasks of files that need to be processed. So like the variable files are read with this. Most of the many-body potential files use potential file reader. We have arginfo because many commands take references to computes, fixes, variables, or custom properties. And so the arginfo class can process them, and you can rather easily determine if it's one of these or how many dimensions it has. So you don't have to write a parser for that in every application. So the parser is essentially in the arginfo class, and all you have to look for is the properties. That's also something that has reduced a lot of code after we introduced that. We have, and that's actually, those existed before, numeric, inumeric, t-numeric. This is for integers and for floating point and integers that do a conversion but check whether they're valid integers. And those have been taken out of the force class, I think where they were, and expand arcs and bounds. I don't know where they all were located. And they're all now in the utils namespace. So that's one of the things that people have to check for if they're porting old code, because that will be incompatible to use. And there's a whole much more convenience functions. So like I mentioned, directory traversal. Sometimes you need to check whether something is a directory, or you want to separate the base name from the file name and the directory name. Or in other cases, you want to have a path variable from joining multiple names, or you need to join just words with like a colon or so to get a string that combines multiples. There are save file read functions where it checks whether the read will actually read something, and then throw an error exception if it doesn't. That helps because otherwise, if you ignore this, then you can get into seg faults or completely undefined behavior, or loops not finishing with the standard fgetS and sfread. I mentioned already LAMMPS, so that's the common function where previously there were places where you had to check for is log file a valid file pointer, is screen a valid file pointer, and then you output the same message to both. This automates this, and also instead of you having doing the formatting yourself with fprintf, you just have an FMT library formatted string that you can pass in. And there's other functions, for example, gets this error, that's just a shortcut to, if you have a C library function fail, you can check for that, like if you do an F open or open potential and that fails, then you want to know why you couldn't open the file. And this will directly give you in a portable fashion the error message that comes from the C library. Typically, you have to look up no, and then there's a str error function that you have to call. So this basically combines this so that you get the last error message of whatever happened.
Quick question, do these platform functions in the first bullet there, do they have if-def code that detects whether you're on a Windows
Yes.
file system or Unix, whatever?
That's usually the difference between utils and platform. Platform is stuff where at least one platform that we are supporting has a different function call or different semantics. I mean, on Windows, there's a difference between binary and text files. Because text files have carriage return line feed, whereas on Unix, you just have line feed. And binary files don't pay attention to that.
So with the path names, is Windows still the opposite the forward slash versus backslash?
Yep.
So does that mean in your input script, if you're running on Windows, you have to use the different characters, or is that the LAMMPS?
So path join, for example, has a define that uses the correct separator string. So it's platform if-def. For split, it uses it supports either.
I guess asking if you put the path in your input script with the file.
Yeah. So if you use a forward slash on Windows, it will still be accepted. I mean, Windows also, if you pass it to Windows directly, it will, in most cases, accept a forward slash, even if you are supposed to use a backward slash. There's a few exceptions to that. And in C, with strings, you have to watch out because the backward slash is the escape character. So you have to give 2 of them instead of 1. Otherwise, you get funny error messages. Yeah, so it works as well as you can make it work. And like with other stuff, so some inspiration has come from Python. I found this a good path because many people are familiar with Python. So if we have semantics that somewhat follow what Python does, I believe that'll be easier for people to write the C++ code. They're not that confident in C++. If they know there's these utility functions that can help them, then they can do. I mean, that's also a good argument for the format library, because it is so similar to format in Python. Yeah, so this is just a different way. So code simplification is what was mentioned before, that we just want to have simpler, by overloading APIs, have simpler ways to do this. But for example, another case where we've taken advantage of this is when you have a create fix or functions add fix or add compute, and a few other cases where you needed to provide an argv list, and that was quite tedious to manufacture. And what we now have is an overload where you can just pass a string, and that one can be easily composed with the FMT format command, for example, from things. Because if you need a fix to add a fix to a compute, for example, typically you want to have an ID that is a modification of the ID that the compute uses, so that they're connected. And here with FMT format, you can just basically put in curly braces and then append or prepend the string you want to add to that compute ID. And then we essentially have just one string with spaces, and then the overloaded function does use the split words on this to build the argv construct, and then passes in it to the actual old style add fix or add compute function. And this way, the programming over it again, it's in many cases where you had 10 or 15 lines of code, you're now down to 2 lines of code. And that also means every line of code you don't have to program is automatically correct. So we have fewer chances for bugs. And this arc reconstruction was something where people were sometimes making bugs because it looked a bit chaotic, and some people that are not, they don't understand what it was really made for, but just were guessing which changes to do, would just get things wrong. And there's always a big risk of messing up the indices. You copy and modify, and then everything is offset by 1 or 2, and then to make those arc readers correct is always a bit tedious. So here, before the break, I have a few examples of how code has changed. So this is like an example for reading a file. So you see here is the repeated calls to SQL talk to get the tokens from the line. So the first one has to take the string. The second one just uses null to get the next string, and then you have the line where it exits if there are no more tokens. And now here we just have the list of words. We can check whether there's enough words, and then you can use the loop construct that was introduced in C++11, where you just loop over the contents of a container. And so the whole code, I mean, you see it's far fewer characters and it's more readable. So that's quite useful.
Axel, does that update the I? Does that increment I?
No. So that's, if you want the increment, that's why it's there. It has to be explicitly incremented in the loop.
So is that supposed to be 0 for B format?
Yeah, it basically starts to, I mean, you're missing the rest of the code.
Oh, yeah. Yeah.
But so that is one of the few things you're losing, because if you have the loop over the contents of a container, it uses the const iterator where possible.
I see. So you have to increment it down below.
Yeah.
Okay.
So and actually, if this is an old copy of the source code, I think by now it probably has 4 const auto reference word to avoid the excess copies. So here's the example of log mask. So this is one case where there's 2 alternatives that would be printed. And so you see you have to check for screen and for log file, and then you have to fprintf to the output. And with log mask, essentially, you don't have to worry about whether it's log file or screen. You just say output it. And you can put the printf is also, the formatting is included directly, because log mask is overloaded in such a way that it takes a format string and then can have a variable number of arguments. So the variable number of arguments is actually the issue that prevented from having this before, because only C++11 allows this from macros, and we need to use a macro to handle this. And C++11 macros can have 3 dots for variable number of arguments. This is the example of the argv construction. So you see how much this shrinks. So this creates 2 computes. And you see in the first case, it needs the ID to store it. So otherwise you could collapse this even further, and you just have modify add compute and put the appending of the index of the underscore press in the format string. But you basically just have a list of the arguments like you would give them on the command line. And then internally, the modifier class will split it back and construct all the active vector as needed. This is an example of a parser. And here also, if you look at this, so a lot of stuff that goes from here and here and here up to about here. So this is here where it has the number of words. That's essentially in these first few lines. Well, everything that's happening here is already the actual parsing. And you see it's structured a bit different because you can, for example, if I want a text, I just say, give me the next string, so you get the next word. But you can also look for numbers, and then you just say next int or next double or next tag int if you need this to be a corresponding long variable. And so that has really massively, you see at the bottom of the left side is the while words less than params per line. And here the reader already has the number of parameters, the number of words per line that's required as an argument when it reads the line. So it's not even checked here in the code, it's checked in the abstracted class. So we're 10:30. I think, well, let's see, we can probably, let me check. Yeah, so let me just do these 2 slides and then we have a break. And then I talk about testing. So just a few comments about what needs to be done if you have external code. So as I already mentioned, LAMMPS, the design is such that it should be easy to add stuff to it, to modify it for your own purposes. And it is just a fact of life that quite a bit of those modifications never make it back into the LAMMPS distribution for multiple reasons. But there's also people now that get just passed a copy of a modified version of LAMMPS with some feature and say, hey, we need to do more simulations with that model. But then you may want to use something that is only available in a newer version of LAMMPS, like the machine learning potentials or some other feature that has been added. And so then you're in a tight spot because then you would have to port all that old code somehow into the new version of LAMMPS. And it may even be that the source code is just in the supporting info of a paper. Sometimes that's the case, or it's somewhere online, but nobody has the time to maintain it. So there's a bunch of these. Often modifications are made by grad students. Once they then find a job as a postdoc, they work on something else, and then it's just abandonware. And that's why we have this one page in the manual now, where we try to describe which changes are required to make the code compile, and some changes are needed, but if you don't make them, the code will still compile. So sometimes those are actually nastier. The ones where it doesn't compile is pretty straightforward. You look at them matching old versus new, and then you know what to make, how to change it. But there's a few more where conventions have changed or extra flags are needed for LAMMPS to work properly with like many-body potentials. There has to be now a flag that says this is a many-body potential. Otherwise, certain checks will not be made that should be. And what we have done also is, or what can be done for this, is to add a plugin loader, which is pretty straightforward to do, so that you can keep your LAMMPS executable and have this extra code in a separate package, and then you use the plugin command to load it when you want it. Because one of the problems with the external code is it's not as well tested. It may have bugs, and you don't want it in your code all the time, or you may not. And also, this is a way how to get support from the LAMMPS developer. So if somebody wants knows about some source code that is publicly available but not up to date. We have this repository LAMMPS plugins, where most of the time it's pretty easy to take some old sources and update them so they compile and run with the current version of LAMMPS. And that's actually how this website, this page in the manual came to be. That's basically the notes that I made while trying to port code. And then I looked up at which version of LAMMPS was this change made, so that you can see if you have a modification that's for version so-and-so, then you may have to make some of the changes, but not all of the changes. And so in the LAMMPS plugins repository, we are much more liberal in which changes, which sources we accept. They basically have to compile and convert it to a plugin. So once they work for that, we offer them, for example, for Windows users who are not used to compiling software, that they can download them as packages from the Windows repository. And it has now been that at least 2 of these plugins have been integrated into LAMMPS itself. So it usually just needs somebody to write the documentation, because most of this external code doesn't have a doc page or maybe just a README, and then it just needs to be converted to fit into the LAMMPS manual. And of course, there has to be some testing and checking. So, but if people verify this, so for the last one that we added this ReboMoss, we're actually in the process of adding it. We A, found a pretty nasty bug, and B, found a way to significantly improve the performance. So people have used the old code, have wasted a lot of CPU time. Okay, yeah, so let's make a break, 15 minutes. Okay, so for the rest of my presentation, I want to talk a bit about testing. And there's a few terms that are common, and just for making sure that we talk about the same thing, I want to just go over this. So there's a lot of theory and discussions about testing in the context of commercial software development. Because if you're a professional software developer, there's rules and there's policies, and companies have requirements how things are done. So in that sense, we have the term unit testing, which means you try to test small individual units. So that's usually like simple functions, a simple class, the tiniest component that you have in your software. And that's supposed to be done by the people who actually write the code. There are some strategies like extreme programming that propose you write the test first and then you implement the feature. That makes some sense actually, because when you write the test, you get clear in your mind about what should the arguments be, what should the flow of control be, and then if you do the implementation, you can do a cleaner implementation. Otherwise, you do an implementation, you write the test, and you see that your implementation should do things differently, and then you have to basically do one more iteration. There's integration testing. So if you have a big project, there's usually different people working on it, and you have to make sure that when you add stuff that it actually works and compiles with everything else. So we do that too. We have lots of tasks when you submit a pull request where it tries to compile on different older, newer Linux versions, other operating systems with different configurations, with the GNOME make build system, with the C make build system, with different combinations of 32-bit and 64-bit choices, and also with GPU support and without. So system testing is when you want to use that executable. So we have something like that as well. So for that, we have what is called run tests, which uses the inputs and checks that all the inputs are still running and not crashing. So it doesn't check the results. That would be then regression testing or acceptance testing, where you test whether the functionality you want to have is actually working the way you want. So there is integrated testing in LAMMPS, and for some arbitrary reason, it's in the folder unit test. It started as unit test, but it actually covers much more. So there are unit tests of like the utils and platform namespaces, where it tests individual functions for behavior if you pass it the correct and incorrect input. That it should have. There are tests for individual LAMMPS commands. Those are a bit problematic for standard test environments because you cannot really use anything that's a command in LAMMPS without actually having a complete LAMMPS instance to work on. And so your testing has to always prepare a system, and it may have to be prepared in a specific way so that the feature you want to try out is actually compatible with it. And that means that the testing is much more complicated, and it's not so easy to always tell whether what you're doing is working the way it should. We have the library interfaces, so there's tests that specifically check the functions that of the library interface, whether they do what they're supposed to be doing. So they're not testing the LAMMPS functionality by itself, but if it calls that functionality the way that the library interface intends. That's specifically important because for the library interface, we expose a lot of the introspection, because that is more needed for the library interface, and you have to go into an existing LAMMPS instance and you have to figure out, is it compiled with feature X, or does a certain condition exist? Is the variable of a kind there? Are you on the right operating system, and more of that, so that then the script or the library function can then adjust what it uses as next command. in part, this is also possible from the LAMMPS input, but it's specifically common that you need this if you write more generic Python wrapper to do complex tasks. Same is true for the Python module. That one stands out because it uses unit testing facility built into Python instead of using the Google test library that we use for the everything else. Yeah, using C++ testing on Fortran is fun because you kind of have to, on top of the LAMMPS C++ to Fortran wrapper, you then also have to do a reverse wrapper that they call Fortran from C++, so that you can check it with the test library. Unfortunately, there isn't anything equivalent in Fortran yet, so it's better to just stick to this. And we have rather complex tests for the force styles. So when we started writing the test, it became obvious very quickly that testing pair styles and bond styles would produce a huge amount of redundant code, because the differences are mostly just the name of the pair style, the arguments, and the coefficients. So for that, we built like generic test programs that read an input file where it has, as encoded in YAML format, has parameters or settings that are to be used for a specific test run. Also, there are multiple sort of template input files. So like that's a generic input file that uses by default pair style 0, bond style 0, angle style 0, dihedral style 0, and improper style 0. So it wouldn't do anything. But then you can, from the tester program, replace selectively any of those so that you're testing then essentially with a full environment, but no forces being or contribution from any of the other styles. So you're testing only the one style that you want to test on. And then you can do very complex tasks. So it writes a restart file, it writes a data file, it reads it back, it builds some input so it can run the single function on it and compares it to what compute does for the same minimal input. And you can run it with Newton on, Newton off, with RRESPA. If you do 1:1 ratio, then it's like velocity Vallée. So you can still see at the multiple levels, you're summing the forces up slightly different. And you go through the different levels of RESPA, but it's just done on the same time step. And all of these are just automatically done so that we have a much wider check and coverage through the individual code, and it's kind of automated to go through all of that. And then there's just some extra tweaks. So we have multiple templates that can be used. There's a different template for many-body tests, many-body potentials, than for molecular potentials they use for molecular cases. And there's also templates for potentials that only make sense for atomic systems. And some are actually tested in multiple ways, like EAM is tested with the many-body setup and the atomic setup because it touches different code paths. And then those testers also support multi-threading and opt package and Intel package and GPU package and focus with multi-threading. So if the corresponding pair style exists, so this is one of the reasons why we have all this introspection, then the test will run the test. So the tester program will run the test, otherwise the tester program will skip it. So you don't really have to change anything if you add more stuff to it, and you get quite an extensive test of the pair style. And if you also enable code coverage, that is easily done in CMake, then you can have data has been collected when you run all the tests of which code paths are used. And then you can convert it with a special tool and get a visualization as HTML pages of the source code where it shows you which code paths are not yet checked. So you'll see that there are some files and code paths that are very well tested and others that still have branches that are untested. So on total, I think we're about 40% coverage, but that includes a lot of the stuff that is commonly used. And a lot of the many code lines are, for example, in the ATC package, which is it's a lot of one-time use code or special case code that only applies to ATC under certain flags. And we don't even have yet an infrastructure for testing that. But there's others that's also, I mean, that this tester programs that work well for styles that are similar, that are matching the conventions of typical inputs. Some stuff, for example, pair style list, where you just provide a list of pairs of atom IDs and it loops over those. That doesn't fit into this scheme at all. So we have to write for these, we have to write separate test programs. And also for those, you just don't want to compare against a reference. This pair style list, for example, is trying to emulate very long distance bond. So you can just make shorter distance bonds and compute with the bond styles and compare against the implementation and pair style list to make sure that both the bond style and the implementation and pair list gives equivalent results. So it's not just that you compare against the reference, but also you have like an internal consistency. Because that would be really bad if you have two different implementation of the same interaction and it comes out different. So then, yeah, I mentioned integration testing before, so we're compiling LAMMPS in many ways. So a lot is run the building over there where we have a bunch of machines, but then other stuff, specifically the native tests on Windows and Mac OS, are run through Azure and GitHub Actions. So why would you want to do all this testing? Because it's a lot of work to write all the tests. And if the code works, but the problem is that a lot of bugs are difficult to judge. Unexpected features show up because you use combinations of features that nobody has thought of before or that haven't been tested. And if I test each part by itself at the lowest level possible, then those unwanted behaviors are less likely because each part, at least by itself, works. And then it's a question of should they work together this way or that way. And also the fine-grained, the more fine-grained, the more low-level the tests are, the more they're unit tests rather than complex regression tests, the higher the chance that you can catch bugs early on. Like I said, often for utility functions, the best strategy is to write the test first and be clear what you want that function to be like, and then do the implementation to match the behavior that's kind of documented in the test. And indeed, that's it's one of the points here. Tests also can be useful in that they demonstrate what is the correct usage of a functionality and what's the incorrect usage. Because if that a test gives you the right error for something that shouldn't be done is as important that it gives you the right answer for something that should be done. So that's, and if you put this all in, it's just, if you write the test, you find naturally that they're easier to write if you write more modular code. So it improves the modularity of the code and reduces the codependencies between branches that are not obvious. We had some of that, but with the testing, we managed to find a lot of things that we didn't know that were connected or dependent on each other. So the code could actually be cleaned up to have a more consistent behavior.
Yeah, excellent. Sometimes look at the Cocos unit tests because maybe there's no example in the documentation. That's the only place I could go.
Yeah, it's really, I mean, like I said, it's really this is where you have to write what you want to happen. And it's sometimes not so easy to really write this down in words. So I understand why it's easier to write code than documentation. I think we're all guilty of that. Yeah, so I cannot stress enough how important it is to not only test for compliance, but also for compliance with the failure behavior. So this is often referred to as a death test, so that the program exits or throws an exception where it should be. This is also something that has helped us now that we used to have two different paths to throwing an error and handling an error, and now we've converged, just have one path that we throw an exception, and then that exception is handled at the top level to produce the error that was previously done directly. And that makes the testing easier because you just have to watch for that exception. And it makes integrating into Python and other interfaces easier because you can now tell the code to proceed beyond that library call. And then the library wrapper will catch the exception and you can check, has there been an error? And then you can handle it accordingly. I mean, for some stuff, the code will just abort or get into a bad shape, and then you cannot continue from there. But at least with the mechanism we have in place, we have now a chance that you can try to recover. It may just be that you have to delete the LAMMPS instance and start over. But we actually had use cases for that. There were people who were just doing bulk testing of parameter scans, and that was done without MPI, so that wasn't actually a problem. MPI is the big unknown in this because you don't have a way in MPI that an exception is replicated across the MPI community. And typically tests are fast. So on the other hand, we have regression tests, which in our case means that we are running full inputs from the example tree, maybe adjusted some parameters so they run a bit faster. But those are really executed, they're executed in parallel, or when Stan runs this also with Cocos on the GPU. And then they have to reproduce the reference output with the given epsilon. So sometimes this is not, we don't have much of that, but sometimes what happens is you find a regression and then a new regression test is basically an input that tries to trigger the bad situation or the situation where the program was behaving badly, even though it shouldn't. And then you add this to your library of tests so to make sure that in future this behavior doesn't come back. We have a few cases where certain code flow looks like it should be done differently. And every once in a while, either one of us or some other person submits a pull request and says, no, this is wrong, it should be like that. And I think for the one case that I remember, there's now a test, and it will just throw a test, and then that's how I recognize that no, this shouldn't be changed. In the other cases, so we have to go the old-fashioned way that we put in a comment that says don't change this. Okay, so continuous integration, I already mentioned this. So basically, it means you have to have dedicated hardware that can be used to run it. And we are triggering this essentially for every pull request, for every merge to the development branch, and for every push to a pull request. And there's a few cases where we have labels that can be added to a pull request to run specific tests that are normally not done. And there we just currently suffering from an undesired feature in Jenkins that whenever somebody modifies the pull request, so if you just modify a text or add a comment, then it triggers running this test. So that's typically, if you want a regression test on a branch or a pull request, you put the label there, you wait until it's started, it triggered, and then you delete the label right away. Because otherwise you will just have another run and another run whenever somebody says, oh yeah, the test passed. And those regression test runs, they just take a long time. Yeah, the whole point of this is to just discover as soon as possible if something's not compatible with exotic combination of compiler flags with different platforms. So sometimes stuff works on the new Linux and not on an old Linux, or it works on Linux but not on macOS or not on Windows. So the classic is the pi constant from the math library. So that's actually non-standard. You have to define a specific define to make it visible according to POSIX. But Linux has it always defined, m_pi, but Windows does not. So you have a code that compiles all the time, but once you have it compiled in Windows, it fails. But then in our case, we actually have the math constant namespace where we want to have those constants to be consistent within LAMMPS, because the platform specific constants also can be different. So that's why you import the mypi and not use mpi. Yeah, oh, this just repeats what I've said. So we're running the combination testing. We're also running unit tests. So using the internal test infrastructure, which requires compilation with CMake and then running the C test, which is part of CMake. There's coding style checks. We're also occasionally run static code analysis. Currently, it's about no, actually, it's with every merge. It runs the code QL, which is provided by GitHub, which is hasn't found many things. But we also have covariety scan. That's about once a week. And that has been pretty helpful because that has found like cut and paste bugs where it said, oh, you put a Z there, didn't you want an X? Or stuff like that. And yeah, also more subtle things. The problem with all static code analysis, there's lots and lots of false positives. It's painful. So yeah, so we have this unit test tree. So it's called unit test, but not all tests are real unit tests. And I mentioned the testers for the 4-style test. So you really set up and run a short MD with like 2 steps and then another 2 steps. And the input is very deliberately chosen that you have a wide variety of forces. So it's not in equilibrium, it's far from equilibrium most of the time. And that's quite helpful because that's where bugs in the algorithm show up more. And we're doing testing for relative error. So that emphasizes them even more because if you have a large force, then it can, if you do look for absolute errors, it can just not be found. But if you check for relative errors, then it is much more sensitive to throw something. The downside is that, for example, if you're testing with multi-threading, you have to multiply the epsilon by a couple orders of magnitude, so by 10 or 100, because the noise that comes from summing up the forces in different order on threads or on the GPU is quite substantial, and that has to be factored in. So there's lots of empirical numbers and heuristics that go into this that make this a bit of a problem. We have some pair styles, specifically those that use spline tables, that are very difficult to check with this kind of test, because in the spline table, you still have this thing that if you hit the spline point, or you're just off by a tiny bit, you get different coefficients, and that multiplies and enhances the differences that you get, even though qualitatively you're still getting the correct result. So EMM is a problem, AIREBO is a problem. So those have to have a rather low epsilon, so a rather large epsilon, so to speak. And up to the point where it gets that it can't catch any subtle errors in. And everything is compared to the same reference. So there's only one reference, which is the output from the plain style. There's no comparing the GPU against the GPU. It always compares against the plain style. So I thought that's just more consistent. And because of that, I found quite a few bugs in the OpenMP package where some details were not quite right. We found quite a few where the single function was not consistent with the compute function. There were just implementations where only the compute function was done and the single function was unchanged. And with these tests, it all showed up. Also, if the data file writing was not writing out all parameters or was not converting the parameters as necessary, restart files were missing values or parameters. So this has found quite a bit. I haven't seen much recently, but I haven't worked much on these recently anyway. Because basically the styles that are easy to do with this kind of tester are done, and everything else is hard. And that usually means that this generic tester can't be used when you have to write a custom tester. Or in some cases, you just need to know the pair style implementation better. There's some stuff I have no idea how it's done. It's quite cryptic. So this is what it looks like if you run the output with the verbose flag. And so you see, effectively, you have multiple categories and substyles where it has groups of tests, and then you see whether the test was done or skipped. So skipping the test means, so we have a few cases where, for example, we know that the implementation doesn't pass the test, but for regular use is correct. So we're skipping the test until somebody has a time enough to figure out why it's failing the test. Yeah, and I mean, you see, there's, for example, also a test for extract, so it checks whether the extract function produces the right a pointer for the known keywords, and the dimensionality is set to the expected value. So I mentioned dev tests. So we also have a few tests for some of the external programs even. They don't use Google tests, they're just test programs that are built to run through the the binary to text uses Google tests. So it basically uses a call system to first run LAMMPS to produce a dump file, and then calls the program to convert it, and then compares it to the dump file that was originally also written in text mode. Code coverage, I think we're around 40% at times.
So I'm curious what that coverage means precisely.
If a line of code has been executed.
And that's 40% of the entire LAMMPS distribution with all packages, or the core, or?
Well, this is counted for everything that's included in the executable. So it works by having an extra flag to the compiler, which instruments the executable, so that the executable will run slower, because it emits a piece of data at every executed line. So it works like with the debugger, you have a mapping of binary code to the source code. And this works similar for every line of source code, it emits a piece of information. So you actually have to compile with minimal optimization to get reliable information. Same as with the debugger. If you use full optimization, you can still use GDB, but then you may do a loop But then you see the source code jump around because the compiler has unrolled the loop. And then you just basically, for each loop iteration, you're jumping back and forth multiple times. And then the iteration counter jumps unexpectedly.
Well, offhand, I'd say 40% is surprisingly high. Yes.
That's just huge.
It's a lot of work. So, yeah, so it's, I mean, Richard was mainly responsible for making this. There's even a website, CodeCoff, where you can see this. So every time it's been compiled, it's actually uploaded there. You can visualize this and see which section of the source code has how much coverage. So there's like a graphical representation where it gives you a red and a to green color scale, depending on how much you have tested. And then it can show you the individual source files where then the functions are highlighted, whether they have been executed during the test or not. But there's also an support for that to do this locally. So if you run this locally, there's extra files that are created for each source file. And then you can run a post-processing tool that will then go through these special files and map that information with the source file. And you basically get a tree of HTML files where you can, that represents the sources. And you can visualize this. I haven't been working much on testing recently, so I haven't done this for a while. But if you're specifically looking for, okay, which is the next the lowest hanging fruit available that you can add more coverage to the tests, that's the tool to use. Or when you write something new and you say, okay, this needs to be tested. And sometimes you write a test and it doesn't execute what you think it should execute. So this gives you the confirmation whether you wrote the right test for the feature you write. I mean, most is obvious, but sometimes it's not. And for that, these tools are really helpful. Okay, so the last thing I want to do is actually take a short tour to some of the test source code and show how it looks like if you run it. So this is now a folder where LAMMPS has been compiled. And so I can run ctest -n, and it will give me a list of all the tests it has. So the testing essentially works this way. There's a whole bunch of executables or entries in CMake to run an executable as a test. So all of these improper style, dihedral style, fixed time step, case-based style, angle style, bond style, pair style. So those all use these tester programs, and there's one entry per YAML file. But for the others, it's one entry per executable. And then inside the executable, you can have, so the executable is basically a collection of test suites or test categories. And then for each category, you can have individual tests. And test means running something and checking whether the result is the expected result or not. So that's in the most generic way. So let's just pick selectively something. Yeah, so the simplest tests are actually in tests for the utils namespace. So I can restrict what to test with the regular expression and the ctest command line. So now this will just run the tests that have utils in the name. So that's 3 tests. So this is the minimum information. If I go verbose, you can see that each of these tests have multiple sub-functions in the test where features are tested. So let's just switch to one of those. So this is the function for the utils test. And with Google test, you start a test by using a macro test, capital test. And that has two arguments. One is the test suite or group of tests. And then that's the individual test, which is a function in this case. And so you see, I'm creating a string where I have some text. And now I'm making a copy of that string using the str.dup function. And then I have to make sure that the copy and the original have the same string. And I make sure that they're not the same pointer. And this assert is then the macro inside that's provided by the test library that can check for certain conditions. And for that, you just have to go through the documentation of Google Test, what available assertions you can use. So you have, this is comparing to some operation. This is for not equal, and they can also test for equal. So here it's testing the trim function. So you see I'm adding some white space and I check whether the result has the white space properly removed. This uses uppercase and lowercase, and you see you want to pass it some complex strings that everything is correspondingly done. And then it just goes through the whole thing step by step, each function. So you see this is all very minimal. But it just demonstrates that the stuff is working as needed. And so whenever you add a new function or you come across a situation where the function wasn't working the way as expected, then you correct the bug and you put in more tests in here to make sure that it's working as expected. So you have split words and for multiple cases. So here the tricky thing is that you have to handle quotes properly, and specifically the triple quote, which has a special meaning in the input parsing. So that needs to be properly treated. And yeah, so just handling quoting correctly, you see there's a whole bunch of tests that make sure that the function that splits the words is actually treating quoted strings the way it needs to for the LAMMPS parser to work. Yes.
Other tests also that check that the math is correct, so that the derivatives of a certain function, like the forces of a pair style, are consistent with the end.
That's what the complex pair style testers are for. So there you're not testing the individual function, but rather you set up a minimal test system that is designed to have is off equilibrium and covers a wide range of the distance area. So you have some in cutoff, some out of cutoff, some close, some far away. And there you just run for 2 steps and you check the forces on step 0 and on step 2. And for those I have references in the YAML file, and they have to be matched up to the given epsilon.
Oh, sorry. I think he was asking, are there tests that the finite difference on the energy matches the force? That's
So that's
LAMMPS command.
yeah, there's a command for that, yes.
But that's not in this testing suite, I don't think, unless you were saying that.
Yeah, so I haven't tried to make this more automatic because the problem with the finite differences is so the tests we have on the pair style, so it assumes that the reference it produces is okay, has been tested. But you can test when you implement it, you can use the finite difference fix to try out that your forces are consistent with the ones that the pair style, for example, the bond style produces.
What's the name of that new fix, relatively new fix?
I think it's fixed finite difference.
Non-diff, or is it finite diff?
No, it's num-diff, yeah. I just looked up.
Okay.
Yeah. And there's a similar one for stress, which is even more problematic because you need the second derivative. So with numerical derivatives, the tricky thing is that you have finite accuracy, and then for double precision numbers, there's actually an optimum delta, and that's about as far as you can drive the accuracy of the numerical differences. So I've used that in the Python code that produces tables. That one you can give it just the function, and it does the forces numerically if you don't have them as a function. And of course we can do that. We do this in the Lepton interface, because the Lepton script allows you to do a symbolic differentiation.
Fixed enough, you're writing in peristyle, fixed enough, stuff. That's
Yeah. Or pair-style Lepton, for example, one-style Lepton.
Yeah.
So indeed, actually, since we're talking about this, so there's also a tester for Lepton. So this is notable because this has to use a different setup. Because I cannot call this because I'm using variables, and I cannot have variables unless there's a LAMMPS instance. So I'm using LAMMPS variables. So essentially what I have now is here I create a class that is derived from a class that we have provided, which in turn is derived from a class provided by Google Tests. So there's a whole bunch of shortcuts and convenience functions in the test infrastructure as well. So there's a LAMMPS test class, which has already enough ready to just run LAMMPS. So effectively now you see we set up the name of the executable, the argument list, and then LAMMPS test setup creates an instance of LAMMPS. And then we do a few extra commands. So we need to define a box and create the box, and then we can use variables. And then here it just calls into the, so to call the Lepton functions, there's a namespace that has utilities for Lepton. So that's what's happening here, where it then has to, for example, simplify the string to match what is required. Because LAMMPS inputs may have quotes that need to be removed. For LAMMPS, they need to be put in there for LAMMPS parsing to that, because you may have string text that has blanks in them. So you have to quote them in the input so they become a single word when it's been passed to the pair style or the pair coef command. And then before you can pass them to Lepton, you have to remove the quotes or the escape characters. So that's what this function does. Then this function does, for example, the substitution. So if you put v underscore name, then it will look if is there a variable by that name, and it will replace the numerical value of that variable in the Lepton expression. This way I can connect the Lepton pair style, for example, to, or bond style to a variable that's been changed by time step, for example. And again, you have to check here. So here I make a substitution with the variable that doesn't exist, and then it has to throw an exception, and I have to catch it here. The difference to the test that I was shown before is now that it has here test underscore f, and the class that was defined up top. So the simple test just create a function. This creates a class instance that is being executed. And then the class has a member function substitute that runs the corresponding test. So in the Google test documentation, they talk of fixtures here. But then this, for example, is a plain Lepton call where it just tests. It has a function CBL that and it checks whether the potential is correctly implemented by Lepton. So this is just using an example that was programmed and check for the numbers. If you do, the numbers come from the corresponding C++ sphere. So, and there's a few more of these. So effectively, you just connect examples where you know there was trouble or where it can be problematic, and so you check to make sure that nothing has changed. So ultimately, what our interest from the LAMP side is if we update the laptop implementation, we want that to behave the same way as before. Or if those tests here fail, we have to figure out why they fail and may need to update either the utility functions or how LAMPS calls the laptop library. And that's the main purpose of having tests like this. But for example, you also have tests for the platform namespace here. And then you see, for example, the clock, it just needs to show that the clock is advancing. But here you have environment variables, and then the tests have to adapt to the operating system. Because, for example, the get env behaves or put env behaves differently on Windows or non-Windows. Because on Windows, if you put env, it will always be set to a value. Whereas on Linux and other Unixes, it can also be set as a variable, but with empty as a value. So in Windows, it will always have the value 1. And so you have to adapt the tests for that. Yeah, so let me show some other tests. So these are tests for commands. So we can, for example, test the variable command. And this is a pretty large test file because, again, it needs to set up a LAMMPS instance. But then it has a convenience function to set up an atomic system, and it has a convenience function to set up a molecular system. It has a convenient function to create files for file style variables. And then so then they have different categories. So for example, here it's testing to create variables and to delete them, and a check. So when we start where it starts with figuring out how many variables are defined, and because it runs the file creation, so there's one default variable that we have when this starts, and then we define a whole lot more, and we have the corresponding assertion here that the number of variables has to be the number 22 after that many definitions. So of course, if I add more, then I have to increase that number. Then we delete a variable, and of course, then n bar has to be 21. So, and then there's like different ways to check for the value. So you see that's the different styles of variables that have to produce different results. So sometimes if it's a string variable, there has to be an extra space. If it's a equal style variable, there won't be an extra space and not an extra 0 here. For vector style variables, it has to follow the convention for vectors that we have established with the square brackets. There's others where it can check whether there's a variable that checks if something is a file or something is a directory. So you see here, you create an empty file, you check whether the file exists, and then you delete the file, and you check whether the file exists, and in one case you get 1, and the other gets 0. So this tries to really check all. And here there was a check against the regular expression for the operating system string. And of course, that's again different for different operating systems. And so on and so on. And it becomes repetitive here. This part I want to point out. So these are dev tests. So this is where you give a command that should trigger an error message. And the first string that I'm checking against here is a regular expression for that error. And that's for commands. This is almost as important as the other tests because we want the code to throw an error when you have an input error. And so, again, you have to be creative to figure out how many different ways can I give a wrong input to that to that program, that command. So you see for variables, there's quite a few. And then, yeah, again, it becomes repetitive. So there's, this one tries to access computes and special functions like the maximum or the sum. And so, yeah, you have these checks on the variable. And again, there's a bunch of death tests. And this tries to test for expressions, so that variables, the plus, the minus, the times, the division, all works as expected. And we have quite a bit of support for different kinds of features in there. So we see again, I don't think this is testing for everything, but some stuff. So, but you see, for example, here, this is just recently added when I added the sort function as a special function for vectors. So that's just an automatic thing. Once you get into the habit that whenever you add a new feature, you write the test, you check on the test, you fix the bugs in your code, because most of the time the test finds a few bugs that you have forgotten about, and so on. And yeah, so from here, it's just, it gets a bit more complex if you want to check the dump commands, because then you have to verify the output of the dump. Or this also checks atom styles. And this is a huge file because this not only checks for compiler for the atom style itself, but connected to that is the functionality to read data files. And so you need to create quite a few data files, and then it also has molecule files. So again, you have the fixture, and then you start with atomic atom style. So it's, you set a bunch of default settings that you want to figure out. And where does it start? This is just setting the defaults. Where's the first test? This is just checking all the settings. So here we're starting with test. So essentially we're creating this state file with the class that was listed before that has default settings. So we're setting now which of the values are expected, different from the default. And then you create this atom style, and you check whether the settings in this expected class or struct match the values that are actually in the atom class. And that's just repeated now for different atom styles. So if you have charge, then there's more information. And of course, you also want to check what happens if you switch atom styles in the input, whether they switch back properly and are properly reinitialized. So that's what's been tested here. And yeah, so then you create some atoms and you check. And then the challenge is often that you need to make sure that you get the right atom, and you know the position for the specific atom by the atom ID, but they may be differently indexed. So there's a macro that we use that identify the atom ID from the tag function, from the tag, and then pass you back or get the map information to give you the real index. And this way you can have a reliable test. Otherwise, if the order of the atoms by some change would be changed, then I mean, you just have to assume that the atoms are created in an arbitrary order in terms of the atom IDs. So that's just a little, this is the part that just makes it a bit harder to read because it's very repetitive. And you want to test everything, you want to make sure that all of that is, and you cannot just do one atom, you have to do a few atoms at least. And you have to figure out when can you stop testing, when is it redundant and when not. But specifically, like for the atomic or charge or full atom style, you want to test as much as possible because those are the ones that are used the most. And then this just goes on. So you have the different atom styles. So we have atom style sphere here, ellipsoid. So that's tricky because you have to dig into the bonus structure. Then also when we did some refactoring of body styles and corrections, I mean, that's been a few years ago. So at the same time, I was just adding testers here, and we could find a few things in the process where it just wasn't perfect. And it's, yeah, so this is really what makes this worth doing, because the good thing is it took some time to implement this and to figure it out. But now it's been executed every time you have a new pull request and an update to a pull request. So it is guaranteed, unless we make a change where some of this information changes, we don't have to touch it and it will pass. And that just gives us a lot of confidence that the code is still working. So what I also want to briefly show, we're almost done. So this is for the C library interface. So in principle, the thing is similar, but here this wants to test the LAMMPS open function in the C library. So we don't need a test fixture because we're actually testing whether we can create the LAMMPS systems. And we want to test it with different arguments. So this is trying to do it with yeah, that's the question of whether you use null or as the end, because there's the old interface where it would return void, but you get the pointer for the handle assigned to the third argument or fourth argument. But we actually discourage this, and now it also returns the pointer. So you can put a null pointer as the last argument. So of course, with the test, you have to test for each version. And you have to test with additional flags, like if you want to enable Cocos, you need more flags. And then you have to check first with the introspection whether Cocos is actually implemented in the binary, because it's not in all test binaries. And then you have here the different functions. So this will always use the default MPI communicator. And that's, we have this one change in, in the library.h. If you don't set a specific define, the library.h will not include MPI.h. So it will always work, even if you have a serial LAMMPS binary where you don't have it. You usually don't ship the stubs library with the shared library in the distribution. And so in this case, you can just basically, normally you can use the open no MPI always, and then it will use the word communicator if it has been compiled with MPI or not. If you want to pass an MPI communicator, you have to use the define to tell the library header that this is supposed to use an MPI.h and have MPI.h installed for the matching MPI library. And then it will include that. So I have to have the tests for that in here as well. And here is the Open Fortran, which is almost the same, but you pass so in Fortran you pass an integer as the communicator because it doesn't, at least at that point, Fortran doesn't have C-style pointers. So it maintains a map where an integer starting from 1 matches the different communicators. And there's a function in the C interface where you can do C to F and F to C. So you can do the opaque communicator, which can be a pointer or an integer, and you convert it to the Fortran communicator, which has to be an integer. And that way you can pass this also to the Fortran interface. So in the Fortran interface, I pass the integer, and then I can assign this to a communicator, because the Fortran, the communicator is an integer. Yeah, so again, and then this has mostly just tests for checking functionality that's specific to the library interface, like the access to properties, to introspection, to use fixed external needs to be hooked up via the library interface, or it's easiest done with the library interface. And we have properties. We have the scatter gather, which is special to the library interface. So I'm trying to specifically test for that. We don't need to test for whether it can run in Leonard-Jones input, for example. So, and now the last group of things I want to show is the folder where the tests are for those complex tester programs. So you see in here, so this is not where the executables are, or the source code. That's actually on the level above, where you have the test programs, and then there are some support functions, for example, for parsing the YAML files, and some of the data structures that the YAML files are matched to in C++. But the interesting thing is really, if you want to look at the some of the individual YAML files. So you see there's a bunch of information in here. So we have all these properties where you have a tag and then assign a proper value to it. So every time you update this file, you get a new timestamp in there, which has the LAMMPS version that it was created with and the date when it was created with. We set the epsilon for the test conversions. That has to be done differently because some pair styles are more numerically stable than others. In fact, this has a special label, unstable, because tip4p has some inconsistencies when running tests, so that people, so Christoph Jungans, for example, when he's running tests for RPM, then he sometimes gets on some platforms on tip4p test failures because it's just a little bit off. And I didn't want to change the epsilon much, to use a much larger epsilon than this. So we just basically agreed that there's a tag here that says this test may fail, and then you can ignore it if it fails on like ARM or something. So then here you have to do some special, so prerequisites are checks that are tested, so the test won't run unless those are available. But then here, these are commands that are run before the template input is read, and post commands are commands that are inserted after the template input is read. And there are some, so this is a pair style that has support for the GPU package, but with the GPU package, I have to make sure that the Newton pair is always off, because the GPU package requires that. And so this is script code that ensures this, that the template is created specifically to not use Newton pair on. Typically, it will try both variants. It will try with Newton pair on and with Newton pair off. And so you see, so this is Coulomb only, so all I have to do is set the pair style with the mapping to the types, and then the pair coefficients are no coefficients for all atom types. But then I can check, for example, for extracting parameters. it checks for the number of atoms. The van der Waals energy will be 0 because there's none of that. And then you have the Coulomb at the initial, you have the stress, and then we have the initial forces for all atoms. And then it does a run for a few steps, and then I compare again. And this is then so you see the numbers here are pretty big. And that's just a consequence of having this one configuration that isn't specifically optimized for anything and very deliberately more high energy so that we get a good sampling of the range of the distances between atoms. And then we have just a bunch more. I mean, this is all repetitive then at some point. So let's say meme. So here we have, our meme is now also on GPU, so it needs to have the same thing. So here we have the coefficient where we map the different elements to the types, but then the rest is the same. And you see this is what's last updated with the same version, but on a different day, and it has a similar epsilon.
So these values for forces and stress, these are the gold standard values that the test is going to compare to?
Yes, so I can actually run this, so let me just demonstrate. So I can go to so I now copied the template inputs and the template data file to my compile folder. So this is the testing program. And I have to give it a YAML file. So let's just copy one of those that we had. So if I just, so what actually happens is that I run the tester on that file. It uses environment variables so that it picks up this from the source folder. So if I want to run it here, I have to copy the files. But what I can do now is I can use the flag -g, and I do new.yaml, and then it changes because it now runs only the part to create those reference data. And I can compare the two files. And now you see this is a different LAMMPS version on a different date, but the data is still the same. And there's a bunch. I can also, there's a bunch of options. So there's a flag -s, where I have it output the statistics over all the forces. So average over atoms, you get how close it matches, and this one is a perfect match, so it's around 0. But for others, you can see how far away they are and whether you have some outliers and or on average how far away. So that's useful for when you set this up and debug. But you can also, if you do -u, then it will actually update the original file. So at the beginning, you don't want to do this because if the calculation fails, then you have an empty file and then you have to create a new one. And I can do -v. I get a verbose output where it not just outputs whether the test has passed or not, but all the LAMMPS commands are echoed and the output is there. So that's what I have to do if the test fails unexpectedly. And that's what I use if, for example, you have made some changes that say it breaks the test. And from this information I get to the screen output, I can then take the template file, make the modifications, and then send it to you as the test input. Yeah, so this part is actually, it's very arbitrary in some way because it has been done very quickly, but with the intent to try to cover as much as possible with avoiding redundant code. So it's hard to explain, it's easier if you just try it out. And in most cases, all you need is just take a YAML file for something that's similar, modify it, and then run with -g and compare the two to see whether it works. And then you can just copy the newly generated as the reference for the new test. And then just also the other thing that you have to do is you have to add it to the CMake that this is a new test. And so you see this one, it doesn't have the full, but close to full set of tests, and we're already at about 600. And if you run them, it takes about 20 minutes or so, depending on how fast the machine is. And on this one, it takes longer because it also does the tests on the GPU with the GPU package, and the overhead to get started on the GPU is quite significant. Okay, yeah, so that's pretty much what I prepared. There's any other question?
I got one question which might be helpful to users for writing code. Can you say something about Valgrind, both for testing your own code as well as how LAMMPS is starting to use Valgrind to do tests of submissions or maybe run regression with Valgrind?
So there is an option, -T memcheck, where I can run all of these tests with Valgrind enabled. That doesn't take 20 minutes. It takes, like, on this machine, a day or two. Because Valgrind is very slow. And this one also produces quite a few false positives because you're leaking memory with every dev test. Because that just aborts, and if you abort LAMMPS, you leak all the memory. The other thing, so what I often do if we have code contributed by somebody that we don't know well, or I look at the source code and say, well, maybe this doesn't look too clean, maybe we should have a second look. And that's where I run compile the executable, typically without optimization. That makes Valgrind a bit slower, but more accurate. And then I just run the input examples that are provided by the submission to see if it has any issues. Memory leaks happen. Nowadays, actually, we have built-in memory leaks from MPI and OpenMP. There are suppression files that I try to maintain that suppress those in the output, but I'm always falling behind because the compilers change and then I have to update these suppressions. Valgrind is, I find it often more helpful than GDB because it is, if you compile without optimization, it's pointing out where there is uninitialized data access is pretty good. Memory leaks is also good except in destructors, because then it's often confusing where the actual leak is. So basically, every time you go to the virtual tables and are not within the pair style, it gets a bit confusing. But it's a weakness of Valgrind, or it's kind of a feature of LAMMPS.
So I'll say for the benefit of you guys who are writing code that you're adding LAMMPS, I think Valgrind is really powerful because it will find bugs, flag things, stare at, figure out why it's flagging, finds things you would never find or think everything was okay, but there really is an issue and you might get hit by it later. And that's true for the memory. There is the false positives, but as you scan, if you see anything with the LAMMPS word in it, capital LAMMPS, that means it's something in the LAMMPS code that it thinks is bad and it's almost over.
So we're trying to be a bit more proactive in that respect. So any pointers that are declared in the class, we're enforcing or encouraging people to set them to null in the constructor. That is because in so many cases that it's much easier to do destroy or delete on the pointer, because those are both compatible with null pointers. But if they're not initialized to null, it can be arbitrary. And then it works until you use clear. And then you get random data where there was a null. So in Linux, the first time you allocate memory, it will be mapped to something that's all zeros. But the second time it will be recycled memory, and then it has random data.
The other thing I'll say from my own experience is you run something, it's just written and it's now given a wrong answer, something's not right. My default instinct is, oh, I'm gonna look in the code, I'm gonna put in some print statements, I'm gonna do something, I'm gonna try to figure out why this is wrong. And then after an hour, I'm still confused, and I say, oh, I should run Valorant. And whoops, 4 or 5 errors pop up, and if I'd done that first, that would have fixed the problem. If I figured out what those values were. So I always kick myself and say, use Valorant if you possibly can. It's going to find lots of bugs that you don't even imagine.
Yes.
So maybe I'm preaching to the choir and you guys already know this, but if not, you should just experiment with that tool.
If anything,
Yeah, but in general, so testing after clear is something that exposes bugs more easily than, so you have to create a system, clear it, and then try again.
Yeah.
So do you remember that I was telling you I had these issues that variables were complaining about circular dependencies?
Yeah.
So I've narrowed it down. I found it only happens when I use the GUI. And when I was preparing the stuff for Monday, I was noticing I had an error in the variable definition. And suddenly the circular dependency thing popped up and it didn't go away. Then I ran from the command line and there was no error. And then I realized the problem is because we're aborting this in progress variable for all this array for all the variables is not reset when you have clear. So basically, one variable evaluation was in progress, and then it aborted, and variables are not, the variable class is not deleted and created, but because the variables remain. So I basically had to put in a call that would clear this flag to avoid the spurious circular dependency.
how does Bargain compare or overlap with the planned address sanitizer?
What do you mean overlap?
Do they fulfill similar functions, or do they overlap a lot, or they're complete independent?
But range with what?
The client address
Address
sanitizer.
sanitizer.
Address sanitizer runs much faster.
Yeah, especially, and you can use it with MPI. Gives us less false positives.
Yeah, but it just doesn't give you as detailed an information. So I have like a standard set of flags that tells Valkyrie to track origins and something else. And that makes a big difference, but also makes it very slow. But you to know the origins, that's often for me the helpful hint to know where some memory that's giving me the wrong behavior or where it's complaining that it's not been initialized. With that, I can know where it was allocated. And that's a very useful piece of it.
If you're getting too many false positives with the uninitialized variables, then you can set a flag to turn that off. Because if you get a undefined read or write, then that's almost always a bug, but you can get a lot of false positives with the variables.
Yeah, so, and also I found that in terms of false positives, OpenMPI cuts a few more corners that trigger false positives in Valgrind than MPitch. So if I use MPitch, I usually compile with use Valgrind, I usually compile with MPitch.
Those OpenMPIers don't have lamps, capital lamps, call trees. So those I just by default ignore. I just don't. I'm looking for lamps.
Yeah, but you still get false positives on LAMMPS data because Valgrind cannot figure out what happens in the MPI functions. OpenMPI does some very nasty magic with how it handles pointers. I presume they do it for a good reason, but it just confuses the hell out of Valgrind. MPitch doesn't, so that's the simple thing to just switch to that. It's a pity because on the other hand, with OpenMPI, you can do the poor man's parallel debugger, which MPitch doesn't support. So you do MPI run, and then you spawn a bunch of X terms, and each X term has the -E flag, which then does GDB minus args and your actual LAMMPS command line. And this way you do MPI run -NP4 and you get 4 X terms. And in each it loads GDB, and then all you have to do is type R for run and enter. And you do this in all 4 and you run in parallel. If you do it with MPitch, they fail because they're not waiting. OpenMPI doesn't wait during init. And so that, I mean, parallel debuggers are just insanely expensive. The only way to use them is that you get an account on one of the supercomputing centers that has to have. And you just only need it like once in a blue moon. So with this trick, I've been getting around that limitation. Because in most cases, if you just run in parallel with Valgrind and just pipe the output to, so error out, send an error to a file, then you can figure out where things are going wrong. But if you have a message where it's sending the wrong value, you need to stop and you need to print from the debugger to see what is that variable and what is the other variable on the other process. Okie dokie, so yeah. That's it.
Thanks, Axel.